This is a completed assembly. It's all glued together. It's got the laser engraving on the back. Beautiful piece of maple on the top. These are the parts that make the smokeless chimney combustion air fan. This fan is spinning at around 2,600 RPM. To make this fan, this part is put on top. And I'll get the mic close. The wood box absorbs a lot of the high-pitched frequency. You still have some air motion. But let me show you how I make this fan. Here we are in Fusion 360. There are 4 parts that I have in Fusion 360 designed. 2 of them 3D printed, 2 of them carved out of wood on a CNC router. The 3D parts take maybe 4 hours to print, and the wood parts take about 20 minutes per side. On a small 180 millimeter print bed, I can get 2 parts, or 2 fans worth of parts. It starts out with 2 pieces of wood, 2 pieces of plastic, the fan, 3 screws from this bin, 3 screws from this bin, 4 pins. We also have some gasketing material. Very nice. The instruments. This is the ping pong ball flow anemometer. This is the hot wire anemometer. These are the air tubes that go with the hot wire anemometer. This is the Dwyer Mark II pressure gauge. This is the gasket material. This is an RPM meter, pair of scissors, needle nose pliers, a pen, and a Phillips screwdriver. I'll spin it up with a 12 volt point the camera at it, or point the microphone at it. That is a very quiet fan, and it's a very pretty fan. All right. This fan has a sticker on it so that we can do a RPM test. So I think you can see this here. So if I do it like this, you might be able to see it. Let's see. Now let's see. I'll get a pan down. Maybe I'll back it up. That's 2,700 RPM. I do have models that'll go up to 5,000 RPM, but this 2,700 RPM is a nice quiet fan. Right at 12.1 volts, 0.11 amps, or 110 milliamps, we have 2,650 RPMs. So let's drop this back to 9 volts. That's 9 volts, or 80 milliamps. And we have, let's see if I can get it right here. We have 2,000 RPM. 9 volts, 80 milliamps, 2,000 RPM. Drop it down to 6 volts. All right, 6 volts, 60 milliamps. $1,325 RPMs. 6 volts, 60 milliamps, 1,329 RPM. It'll run down at 5, so I'll bring it down to 5. Five volts, 50 milliamps, 1,000 RPM, 1,069 RPM. 5 volts, 50 milliamps, 1,069 RPM. Right, we have a velocity measurement set up. So on the left we have the ping pong ball anemometer. This is a hot wire anemometer. Voltage, we'll turn up the voltage to 12 volts. The fan is spinning up. Are we at 12 volts? Alright, so the RPM, we are at, oopsie, 2,650 RPM, 12 volts, 110 milliamps, 2,600 RPM. We have a ping pong ball of 6. We have 787 feet per minute as the velocity. Oh, yeah, I think we're doing okay. I think we're doing okay. Close to 800 feet per minute. I get a slight, if I take off this device, I get a slight rise about to 900. So that's right at 9 CFM. So now what I'll do is I'll dial it down at 9 volts. At 9 volts we have 760 RPM. $2,026. Alright, so let's go down to 6 volts. Here's 6 volts. We have approximately 580 feet per minute, so that's roughly 5.8 CFM. And we have a RPM of 1,300. Now, I know it'll work down to 5, so let's go down to see if we can take it down to 5. Okay, there's 5.1. We have airflow of 5, so that's 5 CFM. At, let's see here, 1,000 RPM. So that's pretty much the bottom of that fan's curve. So in the frame, it's not part of this test. This is a pressure test. We are using the Dwyer Mark II. At 12.1 volts, we are at 0.35 inches of water column. I say that 0.25 is the minimum for a fan and an American wood stove. So if you have a fan and it produces less than 0.25 inches of water column, it is not going to be usable on most American wood stoves. So we've already done the RPM test, but we'll go 12 volts, then we'll drop it down to 9. So it drops down to 0.2 inches of water column. Then we'll drop down to 6. Six volts is about 8 or not, 0.08, 0.09. Looks like it's going to be 0.08 inches of water column. And then we'll drop down to the bottom. Come on. Alright, that's about the bottom where you can control that fan at 5 volts at 50 milliamps at 0.05 inches of water column. There's two things you want to know with a fan. How long it takes to start up, and this one takes about 10 seconds to start up, spin up to full speed when given 12 volts. The other thing you need to know is when you cut the power, how long it takes to spin down and stop. And this fan takes approximately 15 seconds to spin down from a full speed. These are important things to know because when you start a fan, you have to give it a certain threshold voltage. On this fan, it's pretty close to 7 volts that you have to give before it actually will spin. And here I am bumping up the voltage so that we can find the minimum voltage. See, at 6.6 volts, it's just not able to spin the fan quite. It almost is going at 6.6. But I bump it up a little bit more to, I think, 7 volts. You know, it's trying to go, and it might go eventually, but it's not spinning yet. Here we are at 7 volts, and that is enough to get it going. Now, one of the great things about this fan is it never has a really high current draw when it's starting up. A lot of fans that you buy have inrush currents that are very difficult for a PCB or a battery operated appliance to accommodate. And this fan has very low current draw on startup, and that's why it's one of my favorite fans. At 5 volts and at 50 milliamps, we have 0.05 inches of water column. To put this in perspective, this is 1/4 of a watt of power. This fan will run at this USB type voltage, very low current, for hours on a battery. This is approximately an 8 kilowatt fire being spun by this fan, about 5 kilowatts or 5 CFM of air at low pressure, and an 8 kilowatt fire that can heat a small room. One of the reasons I have the fan designed with an open hole on the top, I can put a filter in that hole. However, I don't want to restrict the airflow at this time. But in the dark hours in the morning when I'm trying to start my fire, I like to touch the wheel to make sure it's spinning because I can't really hear it with the other things going on in the room. And it's relatively safe to touch this wheel at 2000 RPM, and you can kind of feel how much power is going into the wheel by touching it. Just to let you know one of the tricks I have. Smokeless Chimney, warm homes and clean air for everyone, bringing wood stoves into the 20th century. Well, the 21st century, maybe even longer. We will see. You can get your products at smokelesschimney.com. This is a QR code. Scan it with your phone.